Okay, I wanted to give some hints about this problem. It turns out that the approach that I suggested during the session is not correct, but this is an interesting problem, and I thought I'd show you some techniques of how you can use this. Now, he may have another method in the book. I haven't actually looked at the book, but there certainly might be other methods of doing this. But it occurred to me that one way to do it is as follows. If you look at the patterns here, you know that the impulse response is going to be a sum of exponentials. So what you want to do is get the coefficients and the powers of the different exponentials. So let me write out what I mean just so I can be clear about that. Okay, all right, so impulse response we often write as h of t or h of n because we are taking the impulse response at integer times. So this is going to have exponential terms like this, plus a2 e to the b2t plus, I'm sorry, that shouldn't be t, that should be an n. Sorry about that. Okay, and let's just say a k e to the b k n. Okay, so the point is to find the a's and the b's. Okay, right now I realize that a possible way to do this. Well, first let me explain how I realized this. If you look at the pattern here, look at the larger numbers, and here you've got 19, 57, 17, 51. The 17 and the 51 really stuck out to me because 51 is 3 times 17. And if you look at 17 and 57, this 171 is very close to 3 times 57. And this 57 is very close to 3 times 19. So what you're doing basically here is multiplying by 3 each time, or something very close to 3. Okay? So what that means in terms of these terms is that this largest term, because I can write this also as a1 e to the b1 to the n plus a2 e to the b2 to the n, and so on. In fact, I could have just written this as a1 z1 to the n plus a2 z2 to the n, and so on, ak zk to the n, where zk or zj is equal to e to the bj. So finding the b's and the z's is equivalent. No difference between them. They're just related by exponential, right? Now let's suppose that z1 is the largest one. So let's suppose this way: z1 is bigger than z2 is bigger than z3, and so on, is bigger than zk. All right. Then what I get here is I can factor out the a1 and then the z1 to the n. And if I factor that out, then I get 1 here plus, and factoring this out basically means that I divide this term by a1 z1 to the n. But I can write it this way: a2 over a1 z2 over z1 to the n. And that goes all the way down to ak over a1 zk over z1 to the n. All right? All right. Now the point is that these terms here, z2 over z1 is less than 1. This zk over z1 is less than 1. So these terms all become smaller and smaller. Okay? All right. So that means that when n is large, you can say something like that h of n is approximately equal to a1 z1 to the n, and times 1 plus something very small. Okay, well, I can just say epsilon. Okay, right. Okay, so that means that h to the n over z1 to the n is equal to a1 times 1 plus epsilon. So that's approaching a1. So this is how I can find a1. All right. Now I saw from this pattern that z1 equals 3. Now hopefully what you can do is use this method to find A1 and Z1. Then you take the rest to find A2 and Z2 and all the way down the line. Okay, so that's the strategy. All right. So we're going to take these ratios. All right. So let's take a look and see how we can do that. First of all, you want to take these. Of course, you want to do this with a computer. You don't want to do this by hand. So please don't do things like this by hand. You can, but really it's a good opportunity to start using the computer to its full power. So what I want to do is get these numbers. First of all, I need to get these numbers in a form I can use them. So I realized that you can actually select the numbers like this, and then go to Excel. I haven't tried this in other spreadsheets, but I think you possibly can do in Google Sheets or LibreOffice. You can try, and then you just paste it here. Okay. Now you notice that here you've got all these numbers like this, not very usable form. So I want to put these numbers in separate cells. So I think this goes to data, and it goes to text to columns, and then it's delimited because there's a space between every data element. Okay, and the delimiter is the space. Okay, so I think I'm done because I have spaces between everything here. Okay, now let's see how this is arranged. 0, 1, 15, and 10, blah, blah, blah. Okay, so how did that come out here? Well, it read across the row. It didn't realize that really this column reads down and this column reads down. It didn't realize that. So so we want to convert this into usable form. So first of all, I need to save this as a CSV file. CSV means comma separated values, and that's a file that can be read by Python or some other language. So I'm going to go to File and then Save As, and then here I don't want Excel Workbook, I want CSV. Okay, so I don't think I want this one. I just want regular plain old vanilla CSV. So we'll do this one. Okay, and I'll just call this let's see, we'll call it impulse response problem. You may notice that when I create file names, I avoid putting spaces in. I think it's a very bad habit to put spaces in your file names because sometimes they cause problems. In modern software, it usually doesn't, but sometimes it does. So I always avoid spaces in my file names. So where did I save this? Oh, it's in my Documents folder. Let me put it on my desktop so I know where it is. Put it somewhere where you know where it is. I'll just put it on my desktop. Okay. So this file is now saved as a CSV file. And that's something I can read with Excel. I'm sorry, with Python. Now at this point, you can open Google Colab, or I myself like to use Anaconda because I'm offline quite a bit. So I'm going to use Jupyter Notebook. If you don't have Jupyter Notebook installed, or you don't have any version of Python, I can certainly help you with that. So let me go here and open Jupyter Notebook. Or you can use some other method for Python. And here I'll start a new, so let's see, where am I? I need to go to my desktop because let's see if I can find my, can I find my file? There it is, impulse response problem. No, I can't open that here, but I should be able to read it. All right, so I'm going to start a new notebook. There we go. And what do I want to do? What I want to do is read that CS. So let me write down what I want to do. I want to, and I think I can do this. I think I can do this, just make it as a quote. And what I want to do is first read a CSV file into Python. And then I want to so I want to read it in as a single array. Okay. Then what I want to do, I want to split the array into 4 parts. So I want to so really what I want to do is reshape the array into a matrix with 4 columns. Okay? And then what I want to do is I want to put the last 2 columns under the first 2 columns. To create a matrix or a 2-dimensional array. Matrix is the same thing as a 2-dimensional array. So create a matrix with 2 columns. Okay, so that's what I want to do. All right, now, since I've clearly expressed what I want to do, I take this and I put it into ChatGPT. Okay, so let's see if ChatGPT can give this to me. Okay, so I go to, you can see I visit ChatGPT quite often. And hopefully my connection will hold up. So this is, so hi, I want to, so let me just add a little bit grammar, read a CSV into as, okay, and then, so I'll put a comma there, and put a comma there, okay, okay, and then here we are. So I think that's probably specific enough to ChatGPT that it was, that we can do this, okay. All right, so let's see. So here it's got my code. So let me go down and see. Now you should always read the explanation. Okay. Now you can kind of look at it first, what it's doing. It's importing NumPy and pandas. Here it's reading, and so you can kind of see that this is the name of my CSV file. Header means so we can read about this. Okay, so we've got this, and then here my result is matrix 2 calls. Okay, so read the explanation. Usually ChatGPT is quite clear the way it puts the code. So I'm going to copy this code. I'm going to put it in my file, and I can put it just like this. Okay, and so let's see. So my file is not my file. So best approach is to make the file name a variable. So what did I call it? I don't even remember. What did I call it? It was called impulse response problem. Impulse response problem. Okay. So this is going to be impulse, whoops, without a 9, impulse underscore response underscore problem dot CSV. Okay, so that's my file name. So I'm certainly going to have to replace that in here. File name. Okay. All right. Now, this is, and there is no header file in my CSV. I just put the value, so that's fine. All right. So this gives the number of rows, matrix 4 columns, matrix 2 columns, matrix 2 columns. Let's see if this works out of the box. Quite possibly it does. So to run this, you can do cell run, or I like to hit Control Enter, and it's running. And there we go. And I think it's right. All right. Now there is a problem here, and the problem is that the values are being truncated. That's a problem. I really need the exact values. So that's a problem when I'm using NumPy. It doesn't. So I can ask for double precision. Okay. So let me go back and see if I can ask for double precision. That might be the easiest way to do it. Okay. Okay. So I want the numbers in double precision. Okay, or you can say the entries of the table in double precision. All right, so let's see. Okay, it says NP float 64. So in fact, they're really they're integers. Okay, so let's see if that gives me a different data type. Okay, so let's try NP int 64. So the only change here was this here, this as type here. So I'm going to grab this and put that in my code and see if that helps at all. All right, so let's see if that is helpful. That was right here. But where did it go? Did it go at the very end? Yes, yes, at the end. Okay. All right, so let's see if that gives me what I need. So control enter, see if that works. All right, now here we go. We've got, this is looking quite good. But it doesn't look so hot at the end. It does not look so hot at the end, unfortunately. But it's good up to 23. Let's give it a shot and see if it's good enough. All right. I'm a little bit concerned about the end because these numbers are not working right. So the way around that would be to use Python lists instead of arrays. But I prefer to use arrays because they're more convenient. All right. So what do I want to do now? Let me think about what I want to do now. Well, let me go up and add some comments to the next part here. Okay. So what I want to do now is I'll put 3 things there for the multi-line comment, and then what I want to do is divide the entries or the values in the second column by 3 to the n. Now in Python, 3 to the n is 3 star star n, where n is the value in the first column. Now here then I'm going to see and then I want to see what the coefficient converges to. Okay. All right, now this here I can do without consulting ChatGPT. If you don't know how to do this, you can consult ChatGPT. But here I'm going to say, let me just call that x1, kind of indescriptively. So now what this is the second column of matrix 2 calls. So that's matrix 2 calls, and I want the second column, which is all rows, and the second column has index 1. And then I want to divide by the first column, zero, a 3 to the power first column. Okay. All right. Now this is not really a systematic way to do a general case here, but I'm just kind of, one thing I want to work out this particular case, and then if I wanted to make a general program to analyze these kinds of sequences, I could make it more general. But just kind of combining my own intelligence with the machine intelligence. Now I really want to put this in a different cell because I don't want to keep doing the same thing. So I'm going to split the cell here. And let's run the second cell because we've already run the first cell. So let's see if we can do this. So let's print x1. Okay, and I'll run this one, control enter, and here we go. All right. Now look at here. Very, very nice. We got 0.75. All right. So, and here you can see 0.75 is pretty much exactly here. But the 0.75 goes off again here. This is an indication that there's round off here. So I'm going to want to get rid of these numbers here because that's going to mess up my estimation of the next coefficient. All right. So how many were good? Well, the last 1, 2, 3, 4, 5, 6. The last 6 were not good. So I'm going to, let's go ahead and create a new cell. Okay. So I'm going to remove the last 6 rows from the matrix. Now what else do I want to do? Well, I know what the first term is now. Going back here, I know what the first term is. So I know now that A1 In our case, A1 is 0.75 and Z1 is 3. Okay, all right. So what do I have here? So now I have h of z. I have h of n is equal to all these terms. I have A1 Z1 to the n 1 plus dot dot plus. Well, let me just write it the first way I had it. Right. That's plus A2 Z2 to the n, and then out to this. Now what I'm going to do is I'm going to subtract A1 Z to the n. Right? And let me subtract off the first term. So that's not h1 anymore. That's h of n minus a1z to the n. Right? And what do I get? Then I get a2z2 to the n plus blah, 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 up to akzk to the n. Okay? All right? All right. Now what I can do, let's do the same thing. Okay? So if we try that, that's equal to a2z2 to the n, 1 plus blah, blah, blah. Okay? Right? Now I'm going to do the very same thing. So I'm going to let you do this and see what happens. Okay? So I'll stop here.